All right, guys, up next we have the ellipse. So we have two different formulas because we have two different kinds of ellipses. We have a horizontal ellipse, we have a vertical ellipse. The difference is where A and B are. If you notice, A is always the longer of the two. So let's see what those variables come from. Where those variables come from? Starting with what is an ellipse? So a circle is the set of points that's equidistant from a center point. Well, an ellipse is similar to that, except it's the set of points that are equidistant where the sums of two distances are the same. So if we look at the distance from the foci to a point and the other foci to a point, that is going to be the same for all the different points. So if we add this distance to this distance, it's going to be the same as if we add this distance to this distance. Okay. So that's what an ellipse is. And those 2 points are called the foci of the ellipse. The major axis is the longer axis of symmetry. Minor axis, shorter axis of symmetry. So if we have a horizontal ellipse, the major axis is horizontal. Vertical ellipse, major axis is vertical. The center is the point at which the minor and major axes intersect. Okay, that'll be important for graphing. The vertices are the endpoints of the major axis. The co-vertices are the endpoints of the minor axis. Do I need you to know exactly what these vocab words mean? No, I just need you to be able to graph it for now. We'll talk about the algebra next week. This week, we're just going to do graphing. So the vertices are plus or minus a units away from the center. So you got your center, your vertices are a units away. If we look over here, a is the denominator here. If it's horizontal, it's on the x. If it's vertical, it's on the y. And b's, plus or minus b is where your co-vertices are from the center. A is always bigger than b. That's just how it goes. Because the major axis is 2a, the minor axis is 2b. Now the foci are a little more complicated to calculate. They're plus or minus c units away from the center. So here's the center. If we have a c from here to here, that's what the foci, the distance from the center to the foci is. So how do we calculate c? It varies depending on what kind of shape we're dealing with. We're dealing with an ellipse here. So c squared is equal to a squared minus b squared, not the Pythagorean theorem. So yeah, we could derive that using Pythagorean theorem and some other stuff, but we're not going to. Just know this form. C squared is equal to a squared minus b squared. And again, we know that a is the distance from the center to the major axis. It's also right here. B, right here. So now we have all that mess out of the way. Let's look at the standard form. Horizontal ellipse, x minus h squared over a squared plus y minus h squared over b squared equals 1. Has to equal 1. So for standard form ellipse, there has to be a plus sign here. That has to equal 1. If we have a minus sign here, that's not an ellipse. It's a different shape. It's a hyperbola, most likely. And if this is not 1, well, make it 1. Divide through by whatever this is, and then you'll have your standard form. So this a and this b can get pretty nasty. But that's our standard forms. Horizontal ellipse, a is on the bottom of x. Vertical ellipse, a is on the bottom of y. So let's just jump into it. All right, I'll do one on here first, and then I'll show you how to do it over on your slides. I'm sure you know how. We just did circles. So center is the first thing it asks for. Well, this is a nice and easy one. Its center is HK. See, HK is your center. There's, oh, wow, I messed up there. I forgot to change that to a K. Sorry if you were looking at that and confused. So the first thing I like to do is look and see, is this a horizontal or a vertical ellipse? Well, which of these is bigger? This is bigger, vertical ellipse. So my A is going to be underneath here, my B is going to be underneath here. So I take the square root to get those. My center is nice and easy, 0, 0. So B is 2, and A is 6. My vertices again, okay, cool. My vertices are again plus or minus A units from the center. Which one though? Plus or minus A here or here? It's a vertical ellipse, so I'm going to add to my vertical value. It's going to be 0A and 0, negative A. 0, 6, 0, negative 6. And my co-vertices go on my minor axis, so that uses B. B is on the X, so I'm going to change the X to 0, negative 2, 0. And then we have to get the foci, so we got to do a little bit of work. C squared equals, and then it's A squared minus B squared. So that's 36 minus 4. That's 32. Square root of that is C. So the foci are kind of nasty to plot. That's about, I'm going to go to the 10th place here. 5.7. Now the foci, if you look, are always going to be on your major axis. So if we have a vertical ellipse here, our foci are going to be on the major axis, which is vertical. So I'm going to change my y values. It's going to be 0, 5.7, and 0, negative 5.7. Because if we look, the foci are plus or minus C units away from the center, and the co-vertices are plus or minus B units, vertices are plus or minus A units, all from the center. We're basically adding a bunch of stuff to the center point. And it's either to the X's or the Y's, depending on if we're looking at the major or the minor axis. So I need to plot these points. So now I'm going to do that over here. Notice I have a red dot, 4 blue dots, and 2 yellow dots. Well, let's let the red dot be the center, the yellow dots be the foci, and the blue dots can be the vertices and co-vertices. The blue are actually on the ellipse itself. The red and yellow, they're actually not on the ellipse, so I'm not going to put those the same color. That's not really part of my graph. The center, 0, 0. Line up a little bit. There, perfect. Not really, who cares? Now I'm going to do my vertices. So on the X, I'm going to go 2 units away. So that's what B is. Close enough. And put this one over here. Then my major axis is 12 units long, so 6 and 6 for my center. A is 6, so I'm going to go 6 units away. Count properly this time. There we go. So that's what my ellipse will be looking like in a minute. Now your foci, that's 5.7 and negative 5.7, so that's going to be right underneath here. I don't need these to be precise at all. In fact, if you don't want to, you don't have to put the foci. I'll be okay with that, because it is a little tricky. Now, how are we going to make this ellipse? Easy. So let's start right here and go down to right here and then move it over a little bit. Should be about right. It's a little wide, so I'm going to shrink it a little bit. Move it over. There we go. I'm still wide. Close enough. So basically what you want to do is play around with it. If you use where these 2 points intersect kind of and go down to where these two, not intersect, but you know, if you go horizontally away from this one and vertically interior vertically under this one, that should be about right. So we look at that, it's good to go. Next. So this one, I'm going to do all on here. So my center is -1, 2. Okay. Now, this is going to be a horizontal one, and A is 7. Oops, I got to hit the text box. So A is 7. E is 3. I'm going to do the work right here in my head. So my vertices, that's 7 units horizontally away from my center. So I'm going to do -1 minus 7 is -8. -1 plus 7 is 6. My co-vertices, I could just copy paste this, save myself a little trouble. These are both going to be -1. Now, it's 3 units away from 2, so 2 minus 3 is -1. 2 plus 3 is 5. Okay, now the foci. All right, let me use my calculator. 49 minus 9 is 40. Square root of 40 is about 6.3. And my major axis is horizontal, so I'm going to change my x value. So -1. I'm going to store this number. Store it to A. Okay, so if I recall A, it's going to give me that. So I'm going to do -1 minus A. And that's going to give me -7.3. Write that down. -7.3. And if I add that, I guess it's going to give me something similar. 5.3. And that's how you calculate your foci. But again, if you don't put your foci, that's all right. 1 minute. All right, guys, I'm back. So let's graph this ellipse. Center is -1, 2. That's going to put the red dot. -1, 2. Adjust a little bit. And I don't need it to be perfect, but might as well do a little bit better. Vertices, -8, 2, and 6, 2. So this is a horizontal one. -8, 3, 6, 8, and 2. And then 8, 2, or 6, 2, sorry. And then my co-vertices, -1, -1. That doesn't seem right. Oh, -1, -1. That's why. Sorry. Got a little lost there for a minute. And then -1, 5. 3, 4, 5. That's about right. I'm going to go ahead and graph my ellipse. Again, you don't have to worry about the foci. So I'm going to see if I can just grab it from here to here. So that's how long that one needs to be. And I need to double this. Oops, keep it there. And go up another 3. That should be about right. Let's see. I can adjust it in a minute if I need to. It kind of likes to grab where it goes. That seems to be pretty nice. That'll work for me. And if you do want to plot the foci, you can. Negative 7.32, so it's going to be right before that. And 5.3. So something like that. Again, if you have your vertices, co-vertices, and center, it's good for me. Foci, they're just a little messy to work with. Okay. That was that one. Now we're on to this one. And as you can see, it's not even close to standard form, so we're going to have to do completing the squares again. So I don't need to see your work, but I am going to do some work over here on my quote-unquote paper. Get that out of the way. Okay, so first thing I'm going to do is I'm going to put the x's together, the y's together, and the number on the other side. Notice this time, I actually do have a coefficient for my x. And if I move that 76 to the right, it's going to be a negative. Okay, so we need to complete the squares for the x's and the y's first. And then we need to divide through by whatever we have over here, so it's in standard form. Because remember, for an ellipse, it has to equal 1. So let's start by looking at this. Remember, we can never have a coefficient in front of our squared term. So if I think about it, if I were to divide through by 4, though, that would give me a 4 on this y here. I don't want that. So instead, what I'm going to do is I'm going to factor out the 4. I'm going to put a 4. And then that's going to be x squared minus 8x. And I'm going to do the shortcut. But to be able to do the shortcut, I need to make sure I don't have any coefficients in front of this squared term. This y squared is nice already, so that's good. So now, I just need to cut this thing in half. X minus 4 squared. And what did I add? I added 4 over 2 squared, or 8 over 2 squared, which is 4 squared, which is 16. However, that's being multiplied by 4. You use your calculator. 8 over 2, I ignored the negative because we're about to square it anyway. Square that. Then whatever you get there, you multiply it by whatever's out here. 64. So that's what I actually added to this left side of the equation. So I need to add that to the right side of the equation. I'll do that in red. Let's look at the y's. Positive 4. Now, what I need to do here is I did 8 over 2 was 4, so 4 squared is 16. I did not have anything out front to worry about. Oops, I dropped off this 4. Sorry, don't drop off that 4 yet. So what I need to do now is add 16 to this side. I added 16 to the left here. I need to add 16 over here. So that's 80 minus 76, that's 4. Just do the arithmetic here. Now this has to equal 1. Also, we don't want any coefficients, so hopefully this cancels out. It does. So we need to divide through by this number right here, 4. And notice what happens. I just get x minus 4 squared. Now this one does have that 4 in the denominator. And it's equal to 1. It's got to equal 1. It equals 1. We're good. We're in standard form. So I'm going to look. It's going to be a vertical one. A is going to be 2. Now, what's the denominator here? Well, you can assume a denominator of 1, right? It's an understood 1 there. So b is going to be the square root of 1, which is also 1. So we've got a, we've got b, we've got our center of 4, negative 4. That's a c equals center. So we've got our center, we got our a, we got our b, we're good to go. Let's go plot it over here. So b is 1, a is 2. Center is 4, negative 4. And really, I'd like to see this simplified standard form equation for this ellipse. That way, if you messed up, I might be able to tell you what you did wrong. So it's x minus 4 squared plus, again, there's no equation here, so we can't put a fraction. Y plus 4 squared. So you could either just do a slash here after the squared, or you can do what I'm going to do is make a space and put a line in there just a second. Equals 1. Good. Better equal 1, right? Now I'm going to do here. 4. I'm going to come in here, draw a line, segment, if it lets me. It did. Okay. If you notice those dots, that was probably my text box. That's good enough. So now I have all that I need. I've got my center. Now, since I'm typing it again. Oops, what did I do? Oh well, sorry. I just kind of put it way too high up here. There we go. Okay, we got the center. Now the vertices. We look at it, it's going to be a vertical ellipse, so my vertices are going to change the y values. So it's going to be same x values. Difference is going to be these y values here. Let's see, what are? Well, a is 2, right? So I'm going to add and subtract 2 to my y value. So if I add 2 to it, I'll subtract first. I get negative 6. If I add 2, I get negative 2. So that's going to be my vertices on my major axis, don't forget. So, co-vertices. That's going to change the x values because it's, again, a vertical ellipse. So the co-vertices are on the x. So those are both going to stay 4s. Well, negative 4, sorry. I'm going to subtract 1, I get 3. I'm going to add 1, I get 5. Foci, again, I'm not too terribly worried about it, but let's do it anyway. A squared minus b squared, and I take the square root of that. I get square root of 3. Again, I'm going to store that to a, because why not? Makes it easier on me in a second. It's a vertical ellipse, because A is over here underneath the y, because A is the bigger one. So I need to change the y values for my foci. So 4 is going to be the x-coordinate. -4 plus square root of 3 is -2.3. So I think I would have copied. Yeah. Okay, -2.3. Pausing. Sorry, I was visualizing that wrong. I was thinking that was my bottom dot instead of my top dot. So yeah, we're good. -5 point something. -5.7. And again, as long as you have your center and your vertices, I'm good with that. Or -4. Right there. And then let's see. Two units away. It's a vertical ellipse. It's a very short vertical ellipse. 1 unit away. Yeah, I'm definitely not going to plot my foci in. It's too crowded already. It's about like that. And again, you can make your ellipse however you want to make it. You can just do this and adjust it at the end if you really want to. Actually, that's not terrible. So I'm going to do my vertical first and adjust that a little bit. That looks very nice. Let's go over here a little bit. A bit less over there. So apparently it doesn't like to go in the middle. There. Well, not too bad at all. And if you wanted to, yes, your foci would go here and here, but again, I'm not that worried about those foci. In fact, I'm not going to put them. And that's it, people. That's how you graph an ellipse. Might want to make it a little thicker. Ta-da. Ta-da. So again, next week, we're going to talk about the algebra behind ellipses. This week, we're just going to do the graphing. I figure all of circles and the graphing of ellipses is enough. That should keep you busy for a little while. But again, if you think about Desmos, you can make a nice eyeball out of some ellipses, you know? And whenever we get to hyperbolas, you could actually make those curves on a Batman symbol. But that's it for today. See ya.